I'm Doug Blank. I'm director of the NX product management team, so responsible for all of our NX simulation product sets. This year, the symposium, we see a lot more of the LMS customer base coming on in and presenting, how they're using the LMS tools, but really seeing the integration of the LMS tool set, 1D simulation, and how that relates to 3D simulation. And also, I think we've seen a lot of where the future of CAE is going. We've seen a lot of higher levels, seeing what the customers in these corporations are looking at and requiring for CAE in the future, and how that's all melding together. And really seeing what Siemens and Siemens PLM can bring to that with our NX CAE product sets and the integration of the LMS product sets.
I'm Nathan Christensen. I'm the manager of the Engineering Tools and Analysis Group at TECH Aerospace Systems. I was really interested in the CAE Symposium this year. Some of the interesting presentations. One in particular was on Nastran optimization. In particular, it was interesting to see the presentation was put together or co-authored with Rescale Computing. Rescale's done a really great job, I think, of putting together cluster computing in a cloud, and partnered with Siemens to offer that as a service, either just as a service with software and Siemens bundling their software in and purchasing software on demand in the cloud. I think that's really the future where a lot of things are going.
We have a number of people working with Siemens PLM on delivering optimized product for graphics, for compute, and for memory within those graphics cards. So the graphics cards are AMD FirePro series products, and they are all optimized to work very efficiently and very precisely with all the Siemens products. In this graphics card that we run during the symposium here, we have up to 5.2 teraflops of double precision, which is phenomenal in terms of providing graphics power and compute power for NX Nastran.
The analysis time spent in NX Nastran is a major contributor to the overall development life cycle. So what we are able to do together with our AMD partners is put together a solution that uses the GPU available on the system to offload a large chunk of a very expensive computation. And utilizing the high flop rates and the larger available memory on the current generation cards, we can solve pretty large analysis problems in times up to half the runtime you would conventionally see on a CPU-only system.
So I'm William Villers. I am a director at TECH LLC, and we do services, so engineering services, design, test, and analysis. We work primarily in the aerospace industry and the defense industry. I think it's been pretty successful. I mean, there was some very interesting presentations, including things that we did not know about from our competitors, and that are going to help us improve our performance in the office. And there was a lot of good insight from larger companies to see where they are with regards to technology. We presented on aerospace defense electronics qualification by analysis, and that's about 70% of what we do on a daily basis. And we presented how NX Nastran fits in this equation.
So I'm Pierre Clairvoyant. I work at ITAC. It's really a first step. So one of the strong focus for the whole industry at the moment is the life prediction of the battery. So you don't want to wait 10 years to see if the battery is going to last 10 years. So this kind of simulation is going to be a strong focus in the next 1-2 years for us. We want to have some very reliable data to show our clients that our designs are able to last through the decade. So this is going to be the main focus for us in the battery modeling. and that's something that LEAPS already does quite well. There's some model with battery aging, so we want to test those models, validate them with our cells, see what kind of results we can get. So yeah, battery aging is going to be the strong focus in the next 1-2 years.
The nice thing about the Siemens acquisition of LMS, as well as some other capabilities that we're looking at and also developing, is that they will have a seamless integration, a way to manage the simulation all the way across the process. And the nice thing about it is that in the whole physical or virtual to physical environment, we will be in a position that we can take that end result, look at the results of that, feed it back into the model and make even further corrections on it. And that starts with the CAE, but that's something, quite frankly, nobody else can do.